want to welcome you to the Dallas Independent School District STEM Environmental Education Center virtual field trip. We want to say a very special welcome to Zan Wesley Holmes, Dallas ISD. Teachers, if you're watching and you have not signed up, please do so. Go to www.tiny.cc/6-8 registration. Sign up for us, please. Program today will be Earth Materials. During this virtual field trip, students will explore a model that illustrates the compositional and mechanical layers of Earth. Students will also classify rocks as metamorphic, igneous, and sedimentary. Mr. Monroe will cover elements of living organisms, elements of solid Earth by Ms. Schramm. Ms. Ramirez, layers of the Earth, and Mr. Dominguez will tell you all about the rock cycle. Students, you cannot ask us a verbal question during this program, but you can go to www.tiny.cc/question-answer, fill out a question about the program, send it to us, and we'll do our best to answer it during the program. If not, I'll send the answer to your teacher. Now I'm going to stop sharing my screen, and Mr. Monroe is going to tell you all about elements of living organisms.
Good afternoon, students. My name is Mr. Monroe, and we're going to be looking at elements that are found in living organisms. And before I really get started in the presentation, I've got a few of my animal friends that I have here in the lab. I know you guys probably get excited about seeing animals, but I'm going to start off by showing you some animals that I have here in my lab. I'm going to start out by showing you one of the last survivors of our pond that recently went dry behind the center. This little fish is considered to be it actually is a crappie, a white crappie. And this little fish probably would be considered to be, not a hatchling, but a fingerling. Very young, okay, very small. Now, if I keep this fish out of the water very long, you guys know that it'll die, right? Well, I'm putting it back in the water. Then I'm going to show you another animal that actually has come from our pond, or didn't come from our pond, but it would be the kind of animal you might find in a pond. And that is Hoppy Jr. Hoppy Jr. is an American bullfrog. And of course, if he was out at our pond and there was water in our pond, we probably wouldn't find him because he would be going through hibernation, because we are now in the season of winter. And he's cold-blooded. He's considered to be an amphibian. And so therefore he would go into hibernation because they don't deal with cold temperatures very much or very well. Okay, the next animal I'm going to show you is a member of the reptile family. And of course, if you were here with us today and we were scheduled to take a nature trail hike, we probably wouldn't see any of these animals like this, simply because they are in hibernation now. This is a three-toed box turtle. It is a female, and her name is Teresa. You can see that right now she's moving around and pretty active, and that's because she's in captivity. If she was out in nature right now, she would be in hibernation. Now, I want you to remember what animals I'm showing you, because I'm going to come back and ask you a question about. I have one more animal I want to show you. And this is Bessie the Quail. Bessie the Quail, she's a quail. Basically, quail are ground birds. They can fly and they can run very fast, but Bessie is warm-blooded. Her body is covered with feathers, and this is a female. So she belongs to the bird family, okay? And then I want to show you this plant that I used in this morning's presentation. We were talking about internal adaptations, and I talked about the vascular system that exists in this plant. The vascular system is made up of its roots, which transports water, its leaves, which transports food to the rest of the plant. But one thing they all have in common, think about it, they're all alive, they're living organisms, right? I'll hurry up and get this one back in the soil, and hopefully it'll continue to to thrive and live, but it's struggling right now. But listen, guys, by now, you've probably been taught that the basic unit of all living things is the cell, right? Now, believe it or not, there are elements that make up the majority of the mass in living organisms. And that's what we're going to be investigating today. And while we're going through this presentation, I want you guys to kind of home in, and I want you to remember which elements make up, or which elements are more abundantly found in living organisms, including ourselves. And then I hope that you'll remember which element is the majority or is the most abundant, okay? One single element is really abundant in living organisms. And when we talk about elements, I know you guys think about the periodic table of elements. Everything that is made up of matter, that made up of the building blocks of matter, atoms, is found, or that scientists know about, is found on the periodic table of elements. Now, the four most abundant elements that are found in living organisms are carbon, hydrogen, oxygen, and nitrogen. And there's an acronym, if you remember this, there's an acronym that will help you remember those four abundant elements. That acronym is TON, C-H-O-N, stands for carbon, hydrogen, oxygen, and nitrogen. Now, actually, there are 6 that are really found abundantly. Oh, there's many more elements that are found, or trace elements that are found in living organisms, even in plants, okay? And there's another acronym, and that acronym is CHNOPS. CHNOPS. And CHNOPS stands for carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Believe it or not, sulfur is actually an element that is found in living organisms. Now, I will tell you this, when we talk about TON, we're talking about the 4 most common. Believe it or not, those 4 most common will make up 96% of a human's weight or mass. Boy, that's really hard to believe, but it does. Now, let me tell you how some of these elements are actually used, okay? Now, if we look at carbon in plants, such as that collard green plant that I just showed you, the mass in plants of carbon is at 12%. The mass in animals is at 19%. And it's found in carbohydrates, lipids, nucleic acids, and proteins, okay? When we talk about another element that belongs to that major group, we're talking about hydrogen. Hydrogen can make up 10% of the mass in plants and 10% in the mass of animals. And it is also found in carbohydrates, lipids, nucleic acids, and proteins. Now, that nucleic acids is found in RNA and DNA. Nitrogen is another element that is found. Now, with the nitrogen, 1% in plants, 4% mass of animals is nitrogen. It's found in nucleic acids and proteins. And then we have oxygen. In plants, oxygen makes up 77% of their mass. And as far as animals are concerned, it makes up 63% of the mass of animals. And it is found in carbohydrates, lipids, nucleic acids, and proteins. Now, oxygen would most likely be the most abundant element found in living organisms. I want you to remember that. And then we have phosphorus. Phosphorus, less than 1% in plants, less than 1% in the mass of animals. And it is found in lipids and nucleic acids. And then we have sulfur. Sulfur is less than 1% in plants and makes up less than 1% in animals, the mass of animals. So you can see, not only is the cell the basic unit of life, but we have elements that are making up most of the mass of living organisms. Now, a lot of the elements that I have mentioned to you, they actually help those cells that make up different tissues. The tissues make up different organs. The different organs make up different organ systems. Guys, they allow those cells to do the specific job. It's what those cells need to do the specific job that they need to do to make our living organisms be able to stay alive. Now, I've run out of time. I'm going to turn it over to Dr. Gorman. So if any of you have any questions, I bet he can answer those for you. You guys have a good day.
Thank you, Mr. Monroe. And the student said, would you repeat those elements? For the mightiest blue whale to the most minuscule paramecium, life as we know it takes dramatically different forms. Nonetheless, all organisms are built from the same 6 essential elemental ingredients: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. And now, Ms. Schramm is going to tell you about elements of solid earth.
Hey everybody, it's me, Miss Schramm, and today we are talking all about the elements of solid earth. So let me get my little thing going. Okay, perfect. Okay, so at the end of my little section, you'll be able to recognize that a limited number of the many known elements make up solid earth. All right, so today's focus questions are: which elements comprise the largest portion of the solid earth? And which element is most abundant in solid earth? So here I have Earth, third rock from the sun. So Earth is one of the 4 terrestrial planets, the inner planets that are closest to the sun. They are called the terrestrial planets because they are made up of rocks and minerals, as opposed to the planets that are the outer planets that are the gas giants. So these are our solid planets. So we have our Earth that is made up of rocks and minerals. So what are minerals? Well, rocks are made of minerals and minerals are made of elements. So it goes rocks, then minerals, then elements, getting more and more specific. So elements are the fundamental materials of which all matter is composed. So let's see, what are the elements? So you saw with Mr. Monroe, the periodic table of elements. So elements are any substance that cannot be decomposed into a simpler substance by ordinary chemical processes. So we've got our periodic table of elements, and some of these are found in solid earth. So let's get going and seeing which ones we've got. So what are the silicates? Silicates are a specific kind of minerals, right? So more than 90% of the Earth's mass is composed of iron, oxygen, silicon, and magnesium. So these are elements that can form the crystalline minerals known as the silicates. So here are some examples of the silicates that make up our Earth. So we got feldspar, mica, pyrazine, quartz, and olivine. Or olivine. All right, so what elements are found on Earth? So there are 92 naturally occurring elements found on Earth, and the different elements make up the Earth's layers. So when we're talking about the solid Earth overall, we can find 92 naturally occurring elements, but as we go from layer to layer, the percentages of how many or the percentages of each element and how many elements can be found there change. So first, we're going to talk about the crust, and you're going to learn about the layers of the Earth in the next segment with Ms. Ramirez, but we'll just briefly cover because it does vary so much between the layers. So the outer layer is the crust, then we have the mantle, and then there's the outer core and inner core. In my little segment, we're just going to talk about the crust, the mantle, and then the core as one. Okay, so in the Earth's crust, I've got a little pie chart to show us the abundance of elements in the Earth's crust. So you can see mostly we got oxygen, Then we have silicone, right? That helps us make our silicates. Then we have aluminum, iron, and calcium, and it goes down from there. So a lot of times when you research the elements of the earth, it'll come up with the top 8, but I included the top 10 just in case. So in case you wanted to get a little more specific. So like I said, 46% is oxygen, 28% is silicon, 8% aluminum, iron 5%, and so on. So as we move into the earth, it changes. So the elements of the earth's mantle, that next layer. So this list, I've only included 4, even though the pie chart shows a couple more than that. But mostly there's oxygen at 44%, magnesium at 23%, silicon at 22%, and then iron at 6%. So you can see that list got a lot shorter and a lot more specific to those couple elements. Then on the inside and the core, we have 85% iron. So that's a big jump from 6% in the mantle, and then all of a sudden in the core, we've got 85%. Then we have 10% nickel and 5% silicon. So that is a big, big difference. Nickel, I don't even think was mentioned on the others. So that is a big jump from 0 to 10, actually. So that is what is at our Earth core, an iron core. All right, so hopefully that is enough to answer our focus question. So which elements comprise the largest portion of solid Earth, and which element is most abundant in solid Earth? And you could probably answer those questions for the different layers. So I'm going to show you, I've got this periodic table, and this one you can of course look it up online too, because you won't be able to see it as well from me showing you, but you can look up these kind of charts. I like this one because it has pictures of what the elements look like. So if it's elements that can be photographed, they have photographs of each of those elements. So let's see if we can find some that were mentioned earlier. So we've got here, we've got iron. There's our iron core. Of course, it's not in the shape of a horseshoe. In the earth, it is molten. So let's see. What else do we have? Here's one. Magnesium, we mentioned that a few times. Let's see. Trying to find like one more good one, but I gotta see where it's at. Well, oh yeah. So we've got our little oxygen up there. So yeah, if you look at the real pictures, it's pretty cool. So I like this poster. If you were here, I will let you look at it. But for now, it's just kind of wobbly when I'm holding it. All right, so I did want to show you one other thing. Since we do have an iron core, here are bits of iron. So iron a lot of times is used for, well, at least in the past a lot, and still used to make tools. So we have a hammer out of iron, and I've got some railroad tires forged out of iron. Getting another railroad tie, and some other crazy things made out of iron, and more tools. So thank you so much. I hope you enjoy the rest of your day and the rest of your field trip. Bye-bye.
Thank you, Ms. Schramm. Question: elements of the solid Earth. More than 90% of Earth's mass is composed of iron, oxygen, silicon, and magnesium, elements that can form the crystalline minerals known as silicates. Thank you again, Ms. Schramm. And now Ms. Ramirez is going to tell you about the composition and the mechanical layers of the Earth.
Hello, my name is Ms. Ramirez, and in this segment, we're going to be learning about the layers of Earth. Now, before we get started, I do want to show you guys a quick animal friend, and that is because, as we know, planet Earth is the only planet that we know of that can sustain life. So be thinking about what characteristics of Earth make it habitable. So one of those animals that exists here on planet Earth is Pelota. She is a ball python. And of course they get that name because when they get scared, they can curl into a tight ball. So these guys are actually native to Africa. She's a reptile. You can see she has scales on her body and she is smelling with that long tongue of hers. So I'm going to go ahead and put her up, but also think about all those wonderful animals that exist here on planet Earth. There's so many cool, interesting ones. So I'm going to go ahead and share my screen and we'll get started so that we can learn about the layers. And I do have a couple of questions for you guys. Hopefully by the end of this presentation, you'll be able to answer these two questions. The first is you should be able to identify and describe Earth's 3 chemical or compositional layers. And the second one is you should be able to identify and describe Earth's 5 mechanical or physical layers. Sorry, my cat does not like the snake friend, so I'm going to make sure the lid is on tight with my snake friend. Ooh, she is hissing in the background, so let me go ahead and make sure the snake friend is safe really quick. So let's go ahead and talk about those compositional or chemical layers. The chemical layers are, there's 3 of them. There's the crust, the mantle, and the core. So what we're going to do, we're going to virtually explore those 3 layers using a virtual solar system scope app. And let me go ahead and get out of this so that you guys can see our website. So let me ask out of this. And this is a free app that you guys can use. It's solarsystemscope.com. Now, since we're learning about planet Earth, we're going to zoom in to planet Earth and we'll take a look at those interior layers. So we're going to focus right now on the chemical layers. They are based on the chemical makeup of each layer. So essentially, it's what elements make up each of these layers. Now, the chemical layers are also referred to as the compositional layers. So you might hear me use those words interchangeably. There are 3 main chemical layers. We have the crust, which is the outer part, the thick mantle, and then we have the core. So we're going to go ahead and start off with the crust. The crust is the outermost solid layer of Earth, and there's actually 2 types of crust. There's a continental, and then there's also oceanic. Oceanic crust is much denser, and continental crust is thicker. And that continental crust is mostly made out of granite and basaltic rock. And as you learned with Ms. Schramm earlier, the crust is mostly composed of oxygen, silicon, and aluminum. So again, the crust is just that thin outer layer. Then we have the mantle. Notice how much thicker that layer is. So the mantle is composed of hot, slow-moving rock. Think of it like the consistency of caramel. It is the thickest layer, as we can see. It's more than 80% of Earth's volume. And the mantle is super important because convection currents cause the plate movement. So the mantle is denser than the crust. And as you learned with Ms. Schramm, the mantle is mostly composed of oxygen, silicon, and magnesium. So now we have our 3rd layer, which is going to be the core. The core is the densest layer. So notice we go from the outermost part, the crust, which is less dense. We go from less dense to more dense as we make our way into the interior. So the core is the densest layer. It's obviously in the center. It's the solid inner core, and it has a fluid outer core made of iron and nickel. Now, the outer core also has convection currents, which power Earth's magnetic field. And again, we know that that magnetic field is important because it shields us from the harmful radiation of the sun. So again, those 3 chemical layers are the crust, the mantle, and the core. And on your own time, you guys can explore this website. You can also compare and contrast the interior of all the other planets as well and see how it compares to Earth. So again, I highly encourage you guys to look at that. You can see here, I just pulled up Jupiter really quick. Notice its atmosphere. Instead of having a crust, it has a thick atmosphere. It has the mantle and a core as well. So you guys can explore that. I'm going to bring us back to our slide presentation. So again, the three compositional or chemical layers are the crust, mantle, and the core. Now in this next slide, we're going to be looking at the mechanical or physical layers. So these layers are going to be based on physical properties, such as, is this layer solid or liquid? How does it move, or how does it transmit waves? And for this one, we're going to use another free app. It's called Earth's Core. We are going to be using the Earth's Core app, and it is a free app that you guys can download for your phone or tablet. I would like for you guys to take a moment to make some observations. What are some things that you guys see or notice about the Earth's structure? So maybe make some inferences about what temperature ranges do you think are in each of these layers? What do you notice about the movement of the rock in each of these layers? Can you identify any of the layers that you're seeing as well? So in this app, we're going to be looking at the mechanical or physical layers. Now, the mechanical or physical layers are so named because they are based on the physical properties of the rock in each of the layers. So for example, is it a solid or a liquid? How does it move, and how does it transmit waves? So when we talked about the chemical layers in the previous slide, there was only 3 layers, right? We had the crust, mantle, and core. When we start talking about the mechanical or physical layers, the mantle is going to be broken down into 3 further layers. Now, an easy way that I remember all of the layers is through a simple sentence, and that is, little animals migrate over Iowa. So let's start with little. Little stands for the lithosphere. So let's go ahead and take a look at the lithosphere. So the lithosphere is the outermost rigid layer, and it's made out of the crust and the top rigid upper part of the mantle. And it's also divided into pieces called plates. So we have little stands for lithosphere. So now we have little animals. Animal stands for the asthenosphere. What do you guys notice about the movement of the rock in the asthenosphere? So the asthenosphere is the layer of weak or soft mantle that is made of rock that flows slowly. So hopefully you guys are able to take a look at some of the magma and the movement of that rock. The tectonic plates actually move on top of the asthenosphere. So animal stands for asthenosphere. So we have little animals migrate. So migrate stands for the mesosphere. The mesosphere is not explicitly labeled in this app, but the mesosphere is the strong lower part of the mantle. And you can see here the lower mantle. The rock here flows even more slowly than it did in the asthenosphere. So hopefully if you guys are looking at the lower mantle, you're able to see that the rock in the lower mantle is more rigid. It's not flowing like it did in the previous layer. So we have little animals migrate over. Over stands for the outer core. The outer core, notice the movement of the rock there. It's like a liquid layer. It's between the mantle and the inner core, and convection currents sustain Earth's magnetic field, and that is in the outer core. So we have little animals migrate over Iowa. Iowa stands for the inner core. The inner core, notice the movement. It's very slow. This is a more solid layer. It has a dense center, and it's the dense center of our planet. So on our next little slide, this is just a quick little review of those mechanical or physical layers. Again, they are separated based on their temperature, density, and viscosity. Viscosity just means how does it flow. And remember that little sentence, little animals migrated over Iowa. Again, we have the lithosphere. the asthenosphere, the mesosphere, the outer core, and the inner core. So this little diagram here on the left is just a quick comparison. We have the 3 chemical composition layers versus the 5 physical or mechanical composition layers. And again, it's important to note that when we're talking about the physical layers, that they are actually breaking the mantle into 3 different layers. So when we talk about the chemical composition, this is the mantle here. When we refer to the mechanical composition, we now have the lithosphere, asthenosphere, and mesosphere. So my little challenge for you guys is to create your own model to represent the Earth's chemical and mechanical layers. So think about what things you have around your house or at school that you can use to help you create your own models. So I'm going to stop my screen share, and that's all I have for you guys today on the layers of the Earth. We're going to give it back to Dr. Gorman.
Thank you, Ms. Ramirez. I did have a question. Describe the lithosphere. The lithosphere is the outermost mechanical layer, which behaves as a brittle, rigid solid. The lithosphere is about 100 kilometers thick. The definition of the lithosphere is based on how Earth materials behave. So it includes the crust and the uppermost mantle, which are both brittle. And what I want you to do, and you probably already know this, it says that it is 100 kilometers thick. How many miles is that? Thank you again, Ms. Schramm, Ms. Ramirez, and Mr. Dominguez is going to tell us about the rock cycle.
Hola amigos, en esta parte de su paseo virtual vamos a explorar el mundo de las rocas. ¿Sabían que hay 3 tipos de roca? Y cada tipo de roca se forma en manera diferente. Hoy les voy a explicar cómo se forma cada tipo de roca. Y también les voy a dar un ejemplo de cada tipo de roca. So guys, in this part of your virtual field trip, we are going to be talking about rocks. Did you guys know that there's 3 different types of rock? And each type of rock is formed in a different way. Today, I am going to explain how each type of rock is formed, and I'm going to show you guys some examples of each type of rock. So let's head back inside so I can give you guys a little demonstration that is going to explain how each type of rock is formed. Let's get started. Ok amigos, antes de empezar nuestra demostración, les quiero introducir a los 3 tipos de roca. Primero tenemos la roca sedimentaria, y la roca sedimentaria se forma cuando pequeñas partículas de roca decompuesta y otras partículas pequeñas como arena y materia orgánica se acumulan unas sobre otras y finalmente se comprimen en roca. Segundo, tenemos la roca metamórfica. La roca metamórfica se forma bajo altas temperaturas y inmensa presión. Y tercero y finalmente, la roca ígnea se forma cuando el magma o la roca que se ha derretido en el alto calor del núcleo de la Tierra se enfría. Ok amigos, vamos a empezar. Alright guys, for this demonstration, all you're going to need is some starburst and access to a microwave. So you can actually try this at home, or if your teacher has access to a microwave, you could definitely try this in the classroom. And what we're gonna do is we are going to simulate what happens in the rock cycle. So how are these rocks formed? And here we have all 3 different types of rock. So we have igneous rock, we have metamorphic rock, and we have our sedimentary rock. This is pumice, and pumice is one of my favorite igneous rocks. It's got a ton of different uses. People use this in the shower, believe it or not. So ask your teacher, they may know what pumice is used for. We have granite. So granite, and granite is a very popular material used in homes for construction purposes. Some of you guys may have granite countertops at home. And here we have sandstone. Like I said, the last type of rock that we are going to talk about today is sedimentary rock. And sandstone is a very beautiful example of sedimentary rock. And how are we going to demonstrate how these rocks are formed using starburst? Well, pretty simple. So we are going to consider our mini starburst our sediment. So, and let's start off with our sedimentary rock, because as you might have guessed, sedimentary rock is formed with sediment. So over time, and by the way, please wash your hands if you are going to eat the starburst after. So over time, and by the way, I am going to refer from now on to our starburst as sediment. So over time, our sediment is deposited on top of each other. So sediment is just, broken down rock particles, minerals. So sometimes you have organic matter, like, dead trees, dead leaves that have broken down into very, very small particles, and that makes up sediment. So all those things make up sediment, and over time, those things get eroded away. They get taken away from one point to another point, and they start stacking on top of one another. And eventually, layers start forming. And what happens when you have that much pressure? Well, let's see. I'm going to take my sediment and I am going to squeeze it. I'm going to apply pressure, okay? Not that much pressure, but you can give it a good squeeze. So just, squeeze your sediment. And what happens? It comes together. And guess what forms? Sedimentary rock. So that's the basics of how sedimentary rock is formed. So now let's move on. How does metamorphic rock form? Well, you just need more pressure and more heat. So what I'm going to do is this time I'm going to squeeze really hard with both my hands. And metamorphic rock, the word metamorphic, or the word metamorphic, metamorphosize, means to change. So what we're doing is we are adding heat because we want this sedimentary rock to change into something else, into something brand new. So I'm adding heat. So I'm taking lots of time and lots of heat and lots of pressure. And what I'm going to do is even squeeze this some more. So more and more pressure will give me metamorphic rock. And check this out. It's a completely different rock now, isn't it? So that's how metamorphic rock is made. It transforms from our sedimentary rock to our metamorphic rock under intense heat and intense pressure. Okay, so that is how metamorphic rock is formed. Now you may be wondering, well, how does igneous rock form? Well, igneous rock is formed when this completely melts down and cools down. So you guys may know what magma is. So magma is the molten rock that can be found inside Earth's core, right, inside the crust. So it comes out of volcanoes as lava. So when that cools down, that molten rock becomes igneous rock, okay? And what we're going to do is we are going to put this in a beaker, okay? We are going to melt it using a microwave and we'll see what happens, okay? So let's go ahead and do that. And remember, safety first. So if you are heating anything up, please have supervision, okay? So let's go to the microwave. All right, guys, as you can see, my sediment has changed. It's still pretty melted, so we can consider this magma. So our magma is cooling down, but we need to let it cool down some more. And when you are doing this, please be careful. Have a parent supervise, because I don't want anyone to blame Mr. Dominguez for getting burns. So we're gonna let this cool down some more. It's pretty cool right now, well, the glass is, but our magma is not. So let's see what we get in a couple of minutes. All right, guys, so my magma finally cooled down. So my molten rock finally cooled down and it formed a completely different type of rock, igneous rock. And teachers beware, I made the mistake of not pouring out our magma from the beaker. I should have done that before and not let it cool down in the beaker. So I'm gonna have to work pretty hard to clean this beaker out. In fact, when getting this out, it actually bent a fork. So our rock has different properties than our previous two rocks. And that's because it underwent a different process to get to this form. So igneous rock is the last rock we are going to talk about today. I hope you guys learned about the rock cycle and how the three different rocks are formed. I will see you guys next time. R.I.P. Beaker.
Thank you, Mr. Dominguez.
Question.
What is the rock cycle in simple words? The rock cycle is a geological process that undergone by the three main rock types, igneous, metamorphic, and sedimentary. This process involves transitions between the three types of rock through erosion into sediment and cementing or heating and pressure. Igneous rock can become sedimentary or it can become metamorphic rocks. Thank you again. And now I am going to share my screen. During this virtual field trip, students explored a model that illustrates the composition and mechanical layers of the earth. Students also classified rocks as metamorphic, igneous, and sedimentary. Mr. Monroe told you about elements of living organisms. Ms. Ram covered elements of solid earth, the layers of the earth by Ms. Ramirez, and the rock cycle by Mr. Dominguez. Thank you so much, teachers, for joining us. If you would, go to www.tiny.cc/6-8 feedback, fill out a very short form and send it to us. We would appreciate it. You guys have a great rest of the day. More importantly, have a great rest of your life.